So our second video from section 7 is going to just focus on the graph of the inverse sine function. What I have on the left side here is the graph of y equals sine of x. And really what we should note here is that if we think of this in terms of the unit circle, the x-axis represents the angle measure, or theta, and the y-axis is representing the y value on the unit circle. So do be careful how you label that, but I just want you to remember that that's really where our sine function comes from. Okay, on the right side though, that is actually what we're going to call the graph of inverse sine. And because we just talked about what happens with an inverse function, one thing to keep in mind as we go through this video is that the x's and y's switch. So now my input is really the y values on the unit circle, and my output would be the angle measure from the unit circle, as we think about how points and coordinates and things like that kind of match up. Okay, so where do these graphs come from? Well, the first thing you should note is that the graph of sine is limited as to what we actually look at. If I were to continue the graph of sine down here, you could see that this part of the graph would not pass the horizontal line test, which means its inverse, the inverse over here, would continue from this spot and go back a little bit. Okay, so remember, we've reflected across to go from this graph to this graph. We reflected across the line y equals x, or we took all the coordinates that we had and we flip-flopped x's and y's, and this is what would match up. And so the issue here now is that this piece right here does not pass the vertical line test. So just like what we did when we went from y equals x squared to the square root of x, when we thought about those inverse relationships, we limited the graph of the function of the square root of x. We need to limit the graph of inverse sine. And so we kind of do the same thing. I'm just going to hopefully erase this here. Okay, and I'll erase this as well. That's where these graphs are coming from. But what I want you to realize is that we only look at a part of the graph of sine to come up with the graph of inverse sine. And I think another important thing that I probably should have mentioned a while ago, I do not need you guys to memorize what the graph of inverse sine looks like. Okay, what I do want you to do is know sine very well, and I want you to realize that inverse sine is only from negative pi over 2 to pi over 2. Beyond that, the function will operate in such a way that we would see repeating y values for a certain x value over here. That would not make it a function. So we've limited it from negative pi over 2 to pi over 2. So you see the circle right here. That represents a unit circle. And the point I have for putting that up there is if I draw in the typical quadrants that we see on the unit circle, we're only, when we're in context of inverse sine, we're only going to be dealing with angle measures from negative pi over 2 to pi over 2, which would be, here's negative pi over 2, we start there, to pi over 2. This is the only part of the unit circle that we're going to be worried about anytime the question is being asked in terms of inverse sine. And that's going to be very, very important down the road. So let's try a couple. If there's any questions with what we've covered so far, just make sure that you ask. But so far, if we looked at a question, it says find the exact value without a calculator of the inverse sine of 1/2. So what I do right away is I'm going to think in terms of, well, this has to, anytime I deal with inverse trig, they're really asking me for an angle measure. So I could say this equals x or equals y, but I'm going to say it equals theta because I know inverse sine, the output up on our graph here, is an angle measure. I want to know the angle measure from the first or the fourth quadrant that will produce this. And then I just rewrite it. I go back and I remember this relationship here that they are reciprocal, I shouldn't say reciprocals, but inverses of each other. And I could say that the question I have right here really means where does the graph of sine of theta equal 1/2? That's really what it's asking me here. So if my output in inverse sine was theta, that's my input for normal sine. So that's why I'm allowed to just rewrite it this way. Okay, so make sure you understand where that's coming from. So now I need to think, where is that true? What value of theta, if I plug it into, there's our fun reminder, If I plug that into sine, what would produce 1/2? Okay, so because sine is positive, it's going to have to be somewhere up here. It's going to be somewhere in the first quadrant. So go ahead and think through that. What would produce a y value that is 1/2? I want you to continue thinking about this and wrestling with radian measure, but if right away, if 30 degrees is what you think of, that's totally fine. But you do want to make sure you realize that's pi over 6 radians. Okay, the next one is a calculator question, and I would like you to get out your graphing calculators and give this a try. We do want this to be in radian mode. If you're in degree mode, you get a different answer, but just practice and make sure you understand how to find the inverse sine function. It's if you find the sine button, you have to hit second, then sine, and type in this value. So this is saying when the y value is negative 0.81 on the unit circle, so somewhere around here on the unit circle, what's the angle measure that would get us that? And so if you do type that in, you should get, let's see, about negative 0.9442 radians. And just to put that into context, that's about negative 54, about 0.1 degrees. So if you think about that, right around here, that would probably be about negative 54 degrees, and that should get us a y value of about negative 0.81. Okay, jot down questions or anything that might be puzzling you, and we'll see you in class.